Hello, my name is Zachary Zhu, and today I will be talking about mean value theorem. Mean value theorem states that if there is a function f of x that is continuous on the closed interval a comma b and is differentiable on the open interval a comma b, then there exists a number c such that f prime of c, or the derivative of f of x at x equals c, is equal to the slope of the secant line that passes through the points a comma f of a and b comma f of b. So this is just a graphical representation of mean value theorem. So we can clearly see that f of x is continuous and differentiable on the interval a to b, and the red line represents the secant line of a to b. So according to mean value theorem, since f of x is continuous and differentiable on the interval a to b, then there exists a value c such that f prime of c is equal to the slope of the secant line. So here the green lines represent two examples of the possible values of c, and in order to prove mean value theorem, we need to use a special case of mean value theorem called Rolle's theorem. Rolle's theorem basically states that if f of a is equal to f of b and the slope of the secant line would be equal to 0, mean value theorem would still apply. In order to prove mean value theorem, we need to understand the intuition behind Rolle's theorem. A of x, b of x, and c of x are three different cases of Rolle's theorem. For a of x, on the interval b to a, we can see that a prime of x is always equal to 0. For b of x, we can see that b prime of x is equal to 0 at one point, or the highest point along the interval b to a, which is the peak of the graph. For c of x, we can see once again that c prime of x is equal to 0 at one point on the graph, the lowest point, also called the trough. In order to prove mean value theorem, for f of x, we need to state that f of x is continuous on the closed interval a to b and is differentiable on the open interval a to b. So the secant line equation of f of x that passes through a comma f of a and b comma f of b is h of x equals f of a minus f of b divided by a minus b, which is the slope, times x minus a, which is the x-coordinate, plus f of a, which would be a y-coordinate. So we know that the secant line would be differentiable and continuous on the interval a to b, since we know that a straight line is a polynomial, therefore it must be continuous and differentiable. We have g of x equals f of x minus the secant line equation, or h of x. We know g of x is continuous and differentiable since f of x is stated to be continuous and differentiable on the appropriate interval, and secant line equations are always differentiable and continuous. So we know that g of a equals g of b, which equals 0, due to h of x equaling f of x at x equals a and x equals b. From Rolle's theorem, we know that g prime of c equals 0 must exist on the interval a to b. So the derivative of g of x at x equals c would be equal to g prime of c equals f prime of c minus f of a minus f of b divided by a minus b, since f of a, f of b, a, and b are all constants, and the derivative of x equals 1. So with a little bit of algebra, we can derive mean value theorem. We know f prime of c minus f of a minus f of b divided by a minus b equals 0, since g prime of c must equal to 0. Therefore, we know f prime of c equals f of a minus f of b divided by a minus b, which is just mean value theorem. Let's go through an example of mean value theorem. Let's say we have a function f of x which is continuous on the closed interval -4 to 5 and is differentiable on the open interval -4 to 5. Let's find a value of x such that f prime of x is equal to f of -4 minus f of 5 divided by -9. If f of x equals x cubed minus 6x squared minus 10x, f prime of x would be equal to 3x squared minus 12x minus 10. We can get that through a simple application of the power rule. So we know that f of negative 4 is equal minus f of 5 divided by negative 9 is equal to 5. So therefore, for at least one value of x, 3x squared minus 12x minus 10 is equal to 5. Through basic algebra, we get that x is equal to negative 1 and 5. However, 5 is not within the open interval negative 4 to 5, so therefore it cannot be a value of c. Therefore, our only answer is x equals negative 1. Let's go through another example of a mean value theorem problem. We have a function f of x which is equal to the square root of 3x minus 3. F of x is continuous on the closed interval 4 to 13 and is differentiable on the open interval 4 to 13. We need to find the value of x such that f prime of x equals f of 13 minus f of 4 divided by 13 minus 4, which is the secant line that passes through the points 4 comma f of 4 and 13 comma f of 13. We know that f prime of x, the derivative of f of x, is equal to 3/2 times 3x minus 3 to the power of negative 1/2 using power rule and chain rule. Here we set the derivative of f of x equal to the slope of the secant line that passes through the points 4 comma f of 4 and 13 comma f of 13. In this step, we just plug in 13 into the original equation and 4 into the original equation to obtain the value of 1/3, which is equal to f of 13 minus f of 4 divided by 13 minus 4. Through algebra, we can simplify our answer to x equals 31 over 4. Since 31 over 4 is within the open interval 4 to 13, mean value theorem is satisfied. So these are some of the common pitfalls for mean value theorem. When you do the problem, make sure you state the continuity and differentiability on the appropriate interval. And when you find the final answer, make sure you only include answers within the open interval, not the closed interval. If the function is not continuous or differentiable on the appropriate interval at any point, then any answer you find is void because it does not satisfy mean value theorem prerequisites. Thank you for watching, and thanks to my sister who helped me film this.